A soap bubble lasts 3 seconds. In that time, light does something it does nowhere else on Earth. Most of us think soap bubbles are just thin water with air inside. That's the intuition we carry from childhood. But there's a reason the colors shift and dance across the surface as you watch. There's a reason a bubble that looks yellow one moment glows green the next. The answer isn't in the soap. It's in how light itself behaves when it hits something impossibly thin. Let's start with what a bubble actually is. It's not a single layer of soapy water. It's a sandwich. Two surfaces of liquid incredibly thin with air trapped between them. At its thinnest, just before it pops, that gap measures around 100 nanometers. For scale, a human hair is 75,000 nanometers wide. You could fit 750 bubbles stacked between a single strand of hair. Now here's where it gets strange. When light enters that thin film, something happens that light doesn't do in normal circumstances. It splits. Half the light bounces off the top surface. The other half passes through, bounces off the bottom surface, and comes back out. Two light waves from the same source traveling slightly different paths. When those two waves meet again, something remarkable happens. They don't just add together. Depending on the thickness of the film at that exact spot, they either reinforce each other or cancel each other out. This is called interference. It's the same physics that makes noise-canceling headphones work. But in a bubble, it's happening to visible light. Different colors have different wavelengths. Red light has a longer wavelength than blue. So at one thickness of film, red light reinforces itself, it gets brighter. But at that same thickness, blue light cancels out and disappears. Shift the angle slightly, the thickness changes infinitesimally, and now green is reinforced while red fades. This is why you see those shimmering bands of color. As you move your head, the angle changes. The apparent thickness of the film changes. Different wavelengths drop in and out of reinforcement. The bubble becomes a living map of light interference, a kaleidoscope written by physics itself. But there's a catch. As a bubble ages, gravity pulls the water downward. The top gets thinner, the bottom gets thicker. Eventually, the top becomes so thinner than the wavelength of visible light itself, that something unexpected happens. The colors vanish. The bubble turns black not because it's dark, but because all visible wavelengths are now canceling out simultaneously. You're looking at a film so thin that it's become invisible. It's not dark, it's absent. This is also why older bubbles are more fragile. As the film thins, the water molecules are stretched across a larger and larger area. Surface tension, the force that holds the bubble together, has to work harder. A fresh bubble can last 10 seconds. A black bubble might last only 1. You might wonder, does this happen anywhere else? The answer is yes. Oil slicks on water show the same colors for the same reason. Thin films of oil create interference patterns. Butterfly wings use the same principle, not pigment, but layered structures so thin they refract light into iridescent blues and greens. Even the shimmer on a CD or DVD comes from the same physics. Microscopic grooves act like thin films, splitting light into interference patterns. What we call the rainbow on a disc is actually light waves canceling and reinforcing each other. So the next time you blow a bubble, you're not just creating a fleeting toy. You're creating a temporary laboratory where light behaves in ways it can't anywhere else. Every color shift is interference. Every shimmer is a whisper of quantum physics made visible. The bubble doesn't know it's temporary. It doesn't know it's fragile. It just exists for its brief moment, bending light into colors that shouldn't be possible, proving that even the simplest moments in nature are built on layers of hidden complexity. And that's the secret life of bubbles, not magic, something better. Physics so elegant it looks like art. Subscribe. Each week we uncover the hidden physics hiding in plain sight, waiting in your kitchen or backyard.